this chapter, we're going to be looking at radicals. In this lesson, we're going to be solving radical equations. But first, we're going to look at restrictions on the variable.
Okay, everybody, in this lesson we're going to take a look at solving radical equations. Okay, so a radical equation is one where the variable is in the radicand. Okay, so the variable is in the radicand. That's how you can identify it. As long as it's underneath the radical symbol, that's a radical equation. So they have both the left side and right side of the equal sign. Your goal is to solve for the variable, and then you do that by eliminating the radical sign. Okay? That is the key to solving a radical equation, eliminating the radical sign. And we'll talk about how you do that just a bit here. So when solving radical equations, you have to take into consider any restrictions on the variables. Because there are restrictions imposed by the radical symbol. Okay? But when you get rid of the radical symbol to solve for it, because you have to do that, sometimes you get rid of the thing that creates the restriction, and as a result, some of your answers don't actually work. So when we change the equation by getting rid of the radical symbol, sometimes we open up the possibility for an answer that actually doesn't work with the equation. Okay, so the restrictions work like this. Since it means that since the radicand must be greater than or equal to 0, the domain is usually found by setting the radicand, and here we go, the radicand greater than or equal to 0, and then solving for the variable. And so we're going to do a few examples of this just so that you can see how this works here. Okay, so the radical equations that we will be solving can have two solutions, one solution, or no solutions. So again, important to remember that as you're going through it, just so that you don't get thrown off. Okay, so mostly by this this no solution thing. Sometimes people get really kind of nervous when they do an equation that's got no solutions, but that's okay. And so here's a couple of examples of what it looks like. Notice that the variable is under the radical symbol. Okay, again, the variable is under the radical symbol, and that's what we're looking for. Now let's talk about restrictions on the variable here. So let's take a look at y equals the square root of x. And we're supposed to sketch this right now. Well, I can't take the square root of negatives, so my graph won't even exist for this portion of the graph. But I can take the square root of 0. When x is 0, y is 0. The square root of 1 is 1. Now, I don't really know what the square root of 2 is. I mean, it's 1.4, blah, blah, blah. I don't really know what the square root of 3 is, 1.7 something. But I do know what the square root of 4 is. The square root of 4 is 2. And so on. So what happens here is the graph looks something like that. That's all I really need here. So what's the domain? Okay, well, the domain of this function is going to be the set of x values such that x is greater than or equal to 0. X is an element of the reals. That's the kind of the formal way of writing that. Okay, so it's the set of x values such that x is greater than or equal to 0. Now, what happens if we change the expression? We look at y equals x minus 2. Well, what does that do to the equation here? Well, I can't take the square root of a negative. I have to take the square root of positive values or 0. So at the very least, I need x minus 2 to be greater than or equal to 0. Now, I can solve for that by moving the 2 over, and I get that x is greater than or equal to 2. Now, actually, what that ends up doing really is taking this graph and effectively moving it 2 units, oddly enough, to the right. So that's going to start right here. It's going to go up here, and then 1, 2, and then it's going to go up to there. So that function's going to look like that. And it is interesting when you see that x minus 2 in there, but actually what that does is ends up moving it to the right a couple of units here. So our domain is going to be the set of x values such that x is greater than or equal to 2, where x is an element of the reals. And now finally, let's take a look at this one. Consider the expression 4 minus 3x. Okay, now I know what a radical function looks like. Okay, I know what a radical function looks like, but I've done some stuff to it here. I don't know. So I can kind of give myself a bit of a head start here by just taking a look at the radicand. Wherever that radicand is greater than or equal to 0, I know that's where my graph is going to be. So I'm going to move the 4 over. Remember, it becomes negative here. And then I'm going to divide by negative 3. And when you divide by a negative, remember that changes the directions of the sign. So what we get here is that x is less than or equal to 4/3. So actually what this does is this kind of flips this thing around, reflects this function here, moves it over here. It's now going to be, it moves it this way, but it's going to open in the other direction here. So 4/3 is going to be somewhere over here. So there's my x-intercept there. Now, if I let x equal to 0, just to get a sense of what this thing's going to look like here, if x is equal to 0, then I've got the square root of 4, which I know is 2. So it's going to open up like this. This is actually going to be quite tall. So anyway, that is roughly what that graph's going to look like, but we've already figured out what the domain is. It's going to be the set of x values such that x is less than or equal to 4/3, where x is an element of the reals. Okay, now let's take a look at some examples. Okay, so for each one of these questions here, we're supposed to state the restrictions on the variable here. So we're basically going to find the domain. Okay, where the variable works here. So here, I simply need the radicand to be greater than or equal to 0, and then as soon as I do that, I'm actually done. So my domain here is going to be the set of x values such that x is greater than or equal to 0, where x is an element of the reals. Now for this one's a little bit more complicated because my radicand is a little bit more complicated. So x minus 3 has to be greater than or equal to 0. That means x must be greater than or equal to 3. So things get shifted over a little bit. And now my domain is the set of x values such that x is greater than or equal to 3, where x is an element of the reals. Now, look at this one. That minus 4 happens after the radical is done, after the root is over. So that negative 4 actually has no impact on the domain of the function. Whatever I'm going to do to x, I've already done it after with the square root there. That negative 4 is happening afterwards. This is actually causing a vertical change here. So the restriction on the variable is that whatever the radicand is has to be greater than or equal to 0. Well, the radicand is just x. So that means my domain is simply going to be the set of x values such that x is greater than or equal to 0. X is an element of the reals. Okay, that's an interesting one. Don't get fooled by that. That minus 4 is not inside the radical. And then finally, this one right here, same thing as we've done for the last few. We're going to take the radicand, set it greater than or equal to 0. Okay, I'm going to bring that 10 over. Now, some of you are probably going to see a bit of a shortcut here, but yeah, I get that. I could move the negative 2 over. That would be easier. But I need to make sure that we're all on the same page with this next operation here. When I divide by negative 2, that changes the direction of the sign. Okay, so now this is going to be x is less than or equal to 5. And so now my domain is the set of x values such that x is less than or equal to 5, where x is an element of the reals. There you go.
Now we'll look at how to solve equations both graphically and algebraically.
Okay, and so now what we're going to take a look at here is how to solve radical equations, and we're going to do this both graphically and algebraically. We're going to cover both types of solutions here, but we're going to start with the graphical solution. So we're going to look at the equation 4 equals the square root of x plus 2. So first of all, we're going to state the values for which the radical equation is defined. Well, we know that that's got to be true where x plus 2, I was just about to write the answer without actually going through the step there. X plus 2 has got to be greater than or equal to 0, and so therefore x must be greater than or equal to negative 2, and so that's our domain, right? Our domain will be the set of x values such that x is greater than or equal to negative 2, where x is an element of the reals. Now, on our graphing calculator, okay, and this is just one way to do this. On our graphing calculator, what they're recommending that we do is we are going to graph both sides of the equation separately. So I'm going to go to y equals and press second x squared to get their square root. I'm going to enter x plus 2. Okay, get out of there. I'm going to go down, and then I'm going to enter 4. So now when I press graph, I'm going to see both of these, and what I'm interested in here is where the graphs intersect. Okay, so there's my x, the root of x plus 2. Oh, and look at that. I can see them approaching each other, but they're not on this screen. Now, interesting thing about the way the Texas Instrument works here is if the point of intersection is above the screen, the calculator will have no problems finding it. But if the point of intersection is to the left or the right of the screen, then it won't be able to find it and it'll give you an error if you try to look. So the first thing we got to do here is extend our window. We just got to make the X maximum, okay, the right hand side, a bit bigger. Let's make it 20. I'm just guessing, okay? I don't know. Let's take a look at it. That looks good. Okay, so it looks like we do have a point of intersection right there. That's awesome. So now second calc, okay, second trace to get into the calc menu, and I'm looking for the intersect feature, number 5. And now the calculator is asking me, am I on the first curve, am I on the second curve? What I would recommend you do is just move your cursor close to that point of intersection. It doesn't have to be right on. When I press enter to say, yes, this is the blue curve is the first one, it's going to jump to the red curve. You can see the color change here. But you'll also see it jump up vertically. Press enter because up on the next curve, it's asking me for a guess. There's no reason why you can't use the calculator's guess here. Press enter again to get past that. And then what we're seeing here, I'm going to zoom in a little bit, is that it's giving me a solution of x equals 14. It's telling me that y is equal to 4, but that's the y coordinate is actually not part of the equation, the original equation. So all I really need is the x coordinate, 14. So this told me that the solution here was 14. Now, does that work? Is 14 bigger than negative 2? Yeah. So I feel pretty good about that answer, but let's double check that. So we've got 4 is equal to the square root of x plus 2. We're going to plug in 14. So 14 plus 2, 4 is equal to the square root of 16. And when I take the square root, I'm going to get 4 is equal to 4. So therefore, the left side is equal to the right side. I know that that it works. Now, I know that seems like a lot of work to do, and clearly the left side is equal to the right side, but we need to make sure that you're communicating very clearly your line of thinking. Okay, later on, when you do a diploma exam, we don't want you to lose marks because you're not being clear. So we really recommend that you include that. So repeat the steps to determine and verify for the radical equation. Now we're going to try this one right here. So to start off, we're going to look at our restrictions for this one. And we're going to get x minus 3 must be greater than or equal to 0. So x must be greater than or equal to 3. So there's where my solution is. Now I'm going to graph this. y1 will be the square root of x minus 3. y2 will be equal to 6. So we're just going to walk through and do the same thing here. So I'll go through and clear that off, clear that off. Now I've already adjusted my window settings, but we'll see how that works. Whoops. So this is going to be the square root of x minus 3. Then I'm going to come down here and put 6 in there. Now we're looking for the point of intersection. And then here's 6. Again, it looks like the point of intersection is going to be way out here, so I have to make my x max bigger again. There's a bit of a difference here. Let's make it 50. Like I said, I'm just guessing here. There it comes. Okay, and once again, I get it. It's almost in the same kind of relative location on the screen. There's my point of intersection. So second trace, intersect. I'm going to move the cursor closer. Enter. First curve, enter. Second curve, enter. Okay, let's zoom in. Looks like my answer is 39. Okay, so we get x is equal to 39. That is bigger than 3, so I feel fairly confident that I did that right there. So let's check this. The square root of x minus 3 is equal to 6. That's the square root of 39 minus 3 is equal to 6. That is the square root of 36 equals 6. So 6 is equal to 6, which means the left side is equal to the right side. I'm good. Okay, excellent. Now, we're now going to take a look at solving it algebraically. Okay, so we wanted to take a look at both kinds of solutions here. Make sure that you're ready. So when we're going to solve these things algebraically, and I'll zoom in so that you can see this a little bit more clearly here, we're going to rewrite the equation so the radical is isolated on one side of the equation. And if there are two radicals, you got to put one on each side. You really want to separate like completely separate at least one of them. So let's say we've got our equation here, don't know what it looked like before, but we moved the 7 over, we've got the radical isolated. Now what we do is we're going to square both sides of the equation to get rid of the radical. But you got to remember to square both sides. Remember that if you're squaring a radical all by its lonesome, all by itself there, all it's going to do is get rid of the radical. So that drops it down to this right here. That square gets rid of the radical and we're left with x plus 3 on the left side. But the 7 squared becomes 49. And then I move the 3 over and I get 46. And there's my solution. Now, I should check that, okay, because it could be an extraneous root. I want to make sure that the left side is equal to the right side. So it could be that what we're looking at here is a root that doesn't actually work in the equation that appears because I made the radical disappear. So we plug it in, 46, so 46 plus 3 is going to be 49. The square root of 49 is 7. That works. Left side equals the right side. I know I'm good. So when squaring both sides of the radical, just to explain what's going on here, the process may lead to an answer which does not satisfy the original equation. This is called an extraneous root, and usually it pops up because of negative terms. Remember, when you square something, whether it's positive or negative, the result is positive. But that original thing that you were squaring could have been positive or negative, and so that's usually the source of our extraneous roots. So the reason for this is that it is possible for two unequal integers to have equal square roots, or equal squares, I should say, equal squares. Okay, so anyway, that's why we need to be on the lookout for it. So now what we're going to do is we're going to take a look at some examples of solving radical equations, kind of both graphically and algebraically. Okay, so for this question here, it says solve each radical equation and determine the extraneous root. Now, when it says that, this really implies an algebraic solution. Okay? And I know that because the extraneous root doesn't pop out when you do a graphical solution. When you do a graphical solution, the calculator will only give you the actual roots. It won't give you the extraneous ones. So this is an algebraic solution here. So let's take a look. Okay, so my first one here is the square root of x plus 2 equals x. Now, I want to isolate the radical. It's already isolated. So now what I'm going to do is I'm going to square both sides, and that's going to get me x plus 2 on the left-hand side because the square will cancel with the radical. Okay, I'm squaring a square root. But on the right-hand side, I'm going to be left with x squared. Okay, well now this is a quadratic. Remember that to solve a quadratic, I got to bring everything over to one side. And then I'm going to factor. Okay, and what are my factors? This is going to be minus 2 plus 1. I'm going to just double check that that works there, and it does. So that means either x minus 2 is equal to 0 or x plus 1 is equal to 0, in which case I know that x is either equal to 2 or x is equal to negative 1. Now what I'd failed to do up at the top here is identify what my restriction was, and I should have done that right from the beginning, and I apologize. I mean, I just went through a couple examples of that's what I did, and then I forgot to. So this is going to be x plus 2 is greater than or equal to 0, which means x is greater than or equal to negative 2. Okay, well, both of these here are greater than or equal to negative 2, so let's just plug them in and check to see that everything works here. If I plug 2 in, okay, so we're going to do the check down here. If I plug 2 in, I'm going to get the square root of 2 plus 2 equals 2. So that's the square root of 4 is equal to 2. 2 is equal to 2. Left side equals right side. I know that that's a solution. Whoa, you can't see that. I'm sorry. I know that x equals 2 is a solution. Over here, I plug that in, and I'm going to get negative 1 plus 2 is equal to negative 1. Square root of 1 is equal to negative 1. And in this case here, the thing you got to remember is that a square root cannot produce a negative result. Okay, when I took the square root of 4, I didn't get plus or minus 2. I just get 2. Okay? When the square root sits there like that. Now, if I was forced to take a square root, like if I was going from x squared to x, well, then I would have the plus or the minus there. Okay, like if I had x squared was equal to 9, then x could be plus or minus 3. But in this case, I don't have that. It's just the square root sitting there. It can only produce one. So left side does not equal right side. So what that means is this is my solution. This is extraneous. No. kind of running into the next question here, but anyway. Okay. Over here, the next question, we're going to do the same thing. First of all, I'll make it clear here. We'll go 49 minus x. We'll take a look at the restriction first. So I know that x here has to be less than or equal to 49. First thing I'm going to do here is bring that 7 over, so it's going to be x minus 7. Okay, so I've isolated the power here, and now I'm going to square both sides. On the left-hand side, that's going to be 49 minus x, but then this becomes x minus 7 squared. And when I do this, oh boy, while you're focused on the radical, don't forget that when you square a binomial, okay, this is like x minus 7 times x minus 7. And so when you do this, you should be getting x squared minus 14x plus 49. I should be distributing both terms to both terms. I should be getting an intermediate term here, a linear term. Now bring those terms over. And again, if you're wondering where that negative 14 came from, just make sure that you're foiling that out if you want to think of it that way. Now the 49s are going to cancel. I'm going to bring that x over, so I'm going to get minus 13x. I'll factor that just like I do with every quadratic if I can, and I'm either going to get 0 or 13. Now, both of those numbers are less than 49. Now let's check. Okay, and I'm going to go back to my original here. So if I go 49 minus 0 plus 7 is equal to 0, well, 49 minus 0 is 49. The square root of 49 is 7, plus 7 is 14. Well, that doesn't equal 0. Left side does not equal right side. I know that this is going to be extraneous. 0 is not a solution to this. Let's try 13. Square root of 49 minus 13 plus 7 is equal to 13. Let's see if that works. Well, 49 minus 13 is going to be 36, plus 7 is equal to 13. 6 plus 7 equals 13. Well, 13 equals 13. That is a solution. That works. So I know that the solution of this equation is 13. Okay, now let's solve a few more here. This one says solve each radical equation. So I tell you what, for the first couple here, let's use the calculator, and then we'll do algebra from that point on. So here we've isolated the radical, which is exactly what we want to do to start off with. And now I'm going to check my domain. So I know that whatever's into the radicand has to be greater than or equal to 0, which means x must be greater than or equal to 6. Now I'm not going to worry about writing out the full domain right now. I'm just going to use this as a check here. So now I'm going to let y1 equal the root of x minus 6. I'm going to let y2 equal 8. So let's take a look at what that's going to look like. So it'll be the square root of x minus 6 and then 8. So let's graph that. So my oh, look at that. Well, they are not going to meet anytime soon here, so I got to change that window setting. I got to make that x max a fair bit bigger. Let's make that 50. We're just guessing here. And now notice what's going to happen here. These still aren't going to meet. That's okay. Okay, just guess again. Don't let that throw you off if you're still having troubles here. Just make it bigger. Let's go up to 100 here. 50 didn't work. Let's try that. That's got to work. And there we go. So we got our point of intersection right there. Another thing I want you to notice here is notice that the graph no longer looks like it's touching the x-axis. That's merely because based on this screen here, how big this screen is, the graph is moving too quickly for the calculator to plot the points accurately. Okay? So don't worry about that. Don't think that all of a sudden something has changed there, because I know a lot of students think, well, the calculator has to give me the answer exactly correct. It's perfect. But the truth is, no, it's not. It just tries its best, and sometimes it can't make things fit using the steps that it's programmed to use here. So now we're going to go second trace. We're going to go down to intersect, move over to that point of intersection, close. I basically press enter 3 times, and notice, whoops, wrong way. My answer looks to be 70. So I'm getting x is equal to 70. Now let's just double check that, make sure that works. So x minus 6 should equal 8. 70 minus 6 should equal 8. 64 should equal 8. Oh, look at that. 8 equals 8. So left side is equal to right side. That is the solution that we're looking for. And now let's take a look at this one. I will do the same thing here. First of all, though, a plus 5, we'll look at the radicand here, has to be greater than or equal to 0. So we know that a must be greater than or equal to negative 5. And now I'm going to isolate the radical. So root a plus 5 will equal 4. And then we'll split it up. Let y1 equal the square root of a plus 5, and we'll let y2 equal 4. Go to the calculator. Whoops, it's off here. So y equals, and I'll make this the square root of, now it's got to be x at this, whoops, what did I do? Let's go back, whoops. Y equals, so the square root of, it's got to be x plus 5. We go down to the next line here, 4. Now, my window setting is, whoops, sorry, that's really shiny here. I didn't look at that. My window settings are going to be kind of out of whack here, so I'm going to press zoom number 6 to have it go back to the original settings here. Let's take a look. Do those intersect? Oh! That's close. Tell you what, we're going to make the window setting just a little bit bigger. Let's just make that 20. It looked like it was intersecting right at the end there, and this way, pretty confident there's a clean point of intersection there. So second trace, intersect, and it looks like the answer there is, whoops, sorry, it's not an answer yet. I haven't pressed the buttons yet to make it solve. So enter, 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 really, and then there it is, 11. So x is equal to 11. Now let's double check that. So the square root of 11 plus 5 minus 4 is equal to 0. That's the square root of 16 minus 4 is equal to 0. So 4 minus 4 equals 0. 0 equals 0. Left side equals right side, so that is a solution. Okay, x equals 11 is our solution. Okay, now with respect to this question right here, actually, you're going to notice, I was going to do this a little bit differently, but I didn't notice this till right now looking at it. This question is actually identical to this one up here. So I tell you what, we did an algebraic solution for this right here. So I tell you what, let's use the calculator, and I'll just show you how this works. Because the question up here did have an extraneous root. Okay, we got the root x equals 2, and then the extraneous root negative 1. So let's just take a look at what happens when I use my calculator. So again, x plus 2 has got to be greater than or equal to 0. If I move the 2 over, I get that x must be greater than or equal to negative 2. Okay? So now, I'll split this up. y1 is equal to x plus 2. y2 is equal to x. And I want you to see what the graph looks like here. If I go y equals here, we'll clean this up here. So first of all, we'll type in the square root of x plus 2. Get out of there, and then we'll put x in the second one. We're going to look for where these intersect. Now, I'd already kind of adjusted my window setting here, but it wasn't too bad here. And now take a look at that. Notice that there is only the one point of intersection here. So I look for my point of intersection, second calc, intersect. Just move my cursor somewhat close to the point of intersection. Enter, enter, enter. And no big surprise there, I get x is equal to 2, which is what I got before. And I've already double checked that. We checked that in a previous question, so you know that that one works here. Now, I want you to understand where that extraneous root is coming from. Okay? When we talk about the square root of a function or the radical, it starts here and goes up. But remember, when we're dealing with, this is really a half of a quadratic. Okay, a radical is like half of a sideways quadratic. If you had the other half of that quadratic drawn down here, that one would intersect with the graph here where x is equal to negative 1. But that's not how we interpret the radical function, so that particular solution is in fact missing. And so that's why we only get this one. But again, you don't see that if you do it algebraically. Sorry, you see it if you do it algebraically. You don't see that if you do it with the calculator. Okay, now for this one right here, first thing we want to do is isolate the radical. It's already been isolated. I know that my solution here must be in the domain where b plus 3 is greater than or equal to 0, which means b must be greater than or equal to negative 3. Now I'm going to square both sides. Now, on the left-hand side, squaring is going to cancel with that radical, so it's just going to be b plus 3. But on the right-hand side, I have to interpret that as that binomial being squared, which means I need to remember to distribute this properly. So I get b plus 3 is going to equal b squared plus 2b plus 1. And that comes from distributing this b to both those terms. It's from distributing the 1 to both those terms. Now bring the b plus 3 over, and we get b squared plus b. I'll subtract a b from both sides, and I'll subtract the 3, so minus 2. Now this is just a quadratic, so I'm going to factor that. And what am I going to get here? It's going to be b plus 2, b minus 1. So I'm going to get the solutions where b plus 2 is equal to 0 or b minus 1 is equal to 0. So b is going to equal negative 2 or b is going to equal positive 1. Now negative 2 and 1 are both bigger than negative 3. So those could work. So let's try checking them here. Let's plug the negative 2 in. So the square root of negative 2 plus 3 would equal negative 2 plus 1. So negative 2 plus 3 will be the square root of 1. Negative 2 plus 1 will be negative 1. Okay, and then we run into this issue again where the values are the same, but the signs are different. See, left side does not equal right side. So I know that that root right there, this is extraneous. Now let's try 1. If I plug 1 in, I'm going to get 1 plus 3, and that's supposed to be equal to 1 plus 1. Square root of 4 is equal to 2, 2 is equal to 2. Yes, left side equals right side. So the solution that we get is this one right here, b is equal to 1. Okay, so let's take a look at this one right here, and we're going to do this one algebraically. Okay, now notice under the radical I get x squared plus 7, and I need that to be greater than or equal to 0. So x squared has got to be greater than or equal to negative 7. Now normally I would take the square root of both sides here, but I just want you to think about this. That's always going to be true. No matter what value I plug in for x, when you square it, you're going to get a positive number. It's always necessarily going to be greater than negative 7. So really this is open up to all values of x here. So now I'm going to, and I should even say that, this is going to be x is an element of the reals here. So now I'm going to square both sides. On the left-hand side, we're going to get x squared plus 7. It's just going to remove the radical. And then over here, it's going to be x minus 1 times x minus 1. So we're going to get x squared plus 7 is equal to x squared minus 2x plus 1. Remember to distribute. This is going to be a big thing, okay? Of all the things we're going to forget, it's going to be to square that binomial here. Now, notice that the x squareds are going to cancel. I love that because this isn't quadratic. Okay, it starts looking quadratic, but it turns out it's not. Those cancel, so we're left with negative 7 equals negative 2x plus 1. So 2x is going to equal negative 6, x is going to equal negative 3. And there we go. Now, let's double check that to see that that actually works. Okay, so if I plug this in, so remember we got x squared plus 7 equals x minus 1. If we plug in that negative 3, so it's going to be negative 3 squared, and remember you're squaring the negative as well. Okay, that negative is going to get squared as well, so it's going to become positive. It's going to be equal negative 3 minus 1. So this will become 9 plus 7 equals negative 4. Root 16 equals negative 4. Whoops, whoa, negative 4. Okay, I can clean that up. I can clean that up. 4. Oh, but then I get that 4 is equal to negative 4, and that's not true. Left side does not equal right side. So it turns out here, this is extraneous. So what does that mean? Well, if the only root I get is extraneous, then that means there's no solution. And that's okay. That's totally fine. Okay. Okay. Now finally in this section right here, we're gonna solve this one that's the cube root of 2x is equal to 4. I've isolated the radical. Now in this case right here, with a cube root, there is no restriction like there is if it's an even root. When it's a square root, I can't let the denominator, actually I can't let the radicand become negative. But with a cubic I can. You got no problem with that at all. And in fact, how I solve this one is I cube both sides. So if you cube the cube root, you get 2x. And then this becomes 4 cubed. Now 4 cubed is equal to 64. Divide both sides by 2 and I get x is equal to 32. So now let's double check that. Does that work? If we take the cube root of 2 times 32, does that equal 4? It's the cube root of 64. 4 equals 4. Left side does in fact equal right side. So yep, that's our solution. That's how you would handle a cube root.